Imagine a highway outside the city. A huge tractor trailer with a tall semi-trailer is traveling along it. The trailer is taller than the cab, longer than several passenger cars, and its side wall looks like a large metal wall. It's traveling at speed, with oncoming trucks passing by. The road curves, and a crosswind is blowing in from the open field. And if you look at this from the side, a simple but very strange question arises. Why doesn't this whole structure tip over at all? At first glance, it all seems almost illogical. A passenger car is low, wide, and short. Its center of gravity is close to the road. With a truck, it's the exact opposite. A tall trailer, a huge lateral surface area, dozens of metric tons of cargo, a long frame, and a coupling between the tractor and the semi-trailer. It seems that all it would take is a sharp turn, a strong wind, or a botched maneuver for the trailer to tip the entire vehicle onto its side. But that doesn't happen every day. These rigs travel thousands of kilometers without incident, transporting food, metal, machinery, furniture, building materials, and almost everything that makes up modern city life. So it's not just sheer luck at work here, but precise engineering logic. The simplest explanation goes like this. A tractor trailer doesn't tip over because it's very heavy. That seems reasonable. A large mass, a sturdy frame, huge wheels, a long wheelbase. But in reality, mass alone doesn't prevent a rollover. Sometimes it even makes the situation more dangerous because the heavier the vehicle, the greater its kinetic energy and the greater the load during a sudden maneuver. What matters more than just how much the truck weighs is where that weight is located, how it's distributed, how high the center of gravity is, and how forces are transmitted throughout the entire structure. This is where it gets important. Any tall vehicle acts like a lever when turning. When a tractor trailer turns, its mass tends to keep moving straight ahead. A lateral force arises that seems to push the vehicle toward the outside of the turn. If this force is too great, the inner wheels begin to lose traction. At first, they simply exert less pressure on the road. Then, they may almost lose contact entirely. And once the limit is exceeded, the vehicle can no longer correct itself. It begins to tip over onto its side. This risk is particularly noticeable with a tall semi-trailer because its center of gravity can be quite high. If the trailer is loaded with light, bulky cargo that reaches the ceiling, the danger is less than it seems. But if heavy cargo is stacked high, if the pallets are poorly distributed, or if the cargo shifts, the center of gravity rises, and then the very same turn that was safe yesterday can become dangerous today. From the outside, the truck looks almost the same, but its stability on the inside has already changed. That is precisely why a tractor trailer is not designed like a regular vehicle. The main secret starts with the fifth wheel. This is the massive fifth wheel coupling behind the cab, into which the semi-trailer's kingpin fits. At first glance, it looks like a simple coupling, but in reality, it's one of the key elements of the entire system. The fifth wheel doesn't just pull the trailer. It absorbs part of the vertical load from the semi-trailer and transfers it to the tractor's frame and drive axles. Thanks to this, the tractor doesn't just drag a huge trailer behind it. It becomes part of the overall support system. The weight of the trailer presses the tractor's drive wheels against the road. This improves traction, acceleration, and braking, but a precise balance is needed here. If the load on the fifth wheel is too light, the tractor loses traction. If it's too heavy, the axles, tires, suspension, and frame become overloaded. Therefore, a truck's stability does not come from a single large mass, but from the correct distribution of that mass between the tractor's front axle, the drive axles, the fifth wheel, and the semi-trailer's axles. But a tall trailer isn't dangerous just because of its weight. It also catches the wind. Its sidewall acts almost like a sail. When a strong wind blows against a passenger car, the area exposed to the wind is relatively small, but when the wind hits a tall semi-trailer, the force acts over a large surface area and creates a torque that tries to tip it on its side. And here, many people mistakenly think that a powerful engine solves everything, but the engine doesn't cancel out the crosswind. It can pull the load forward, but it can't eliminate the force pushing from the side. The real challenge lies in the details. The tires, suspension, track width, center of gravity, and speed. On a straight road, the wind simply pushes the trailer. In a turn, Lateral inertia adds to the wind's force. A sudden lane change creates an even more complex situation. The tractor has already changed direction, but the long trailer reacts with a delay. It does not behave like a single short vehicle. It has its own mass, its own length, its own axles, and its own trajectory. Therefore, a truck driver is not simply driving a vehicle, but a long system where every sudden movement can result in an amplified reaction from the rear. The coupler between the tractor and the trailer is crucial here. On the one hand, it seems like a weak point. After all, the combination could tilt at a dangerous angle. On the other hand, without it, such a long vehicle wouldn't be able to turn properly at all. The coupler allows the tractor and semi-trailer to adjust their angle relative to each other. At low speeds, this provides maneuverability. On the highway, it requires smooth driving. The trailer does not follow the tractor's path instantly, so an experienced driver thinks ahead not only about the cab, but also about where the rear of the trailer will be in a second. But why doesn't the tractor roll over immediately if the trailer starts to tilt? Because the system isn't completely rigid. The frame, suspension, tires, and coupling all work together. They deform slightly, distribute the load, and absorb sudden impacts. In heavy-duty vehicles, flexibility is often not the enemy of strength, but rather an integral part of it. If everything were built like a stone beam, the loads from the road and the trailer would be transmitted too abruptly. The vehicle would become less predictable, and its components would wear out faster. The suspension here isn't just for comfort either. It maintains tire contact with the road, distributes the load between the axles, and affects how the car leans into a turn. The tires convert mass into traction. The frame absorbs bending and torsional forces. The trailer axles support the rear and create a wide contact patch. Taken together, these features don't eliminate the risk, but they push the limits. The vehicle may lean, feel the wind, or take a turn under load, but as long as the forces remain within the acceptable range, it returns to equilibrium. A rollover doesn't start when the trailer simply tilts. A tilt in itself isn't a disaster yet. The danger begins when the center of gravity moves beyond the support area. Simply put, as long as the weight and lateral forces are still within the area between the wheels, the vehicle tends to stay upright. But if that invisible line moves outward, gravity no longer pulls the trailer back. Instead, it helps it fall. That's exactly why, in accidents, a truck often looks like it's just tilting at first, and then suddenly crosses a threshold beyond which it's impossible to bring it back. There is another important factor: loading. The same tractor-trailer combination can be stable or dangerous depending on what's inside. Heavy cargo should be placed lower down. The weight must be distributed correctly along the length of the vehicle. The cargo must be secured so that it does not shift when turning or braking. If everything inside is loaded incorrectly, the engineering logic breaks down. The vehicle looks the same on the outside, but its behavior changes. Tankers are a particularly challenging example. In a box truck, the cargo usually remains stationary, but in a tanker, the liquid can move around. When braking, it surges forward. When turning, it presses against the sides, and during sharp maneuvers, it begins to sway. This creates additional stress precisely when the vehicle is already under strain. That is why tankers have internal partitions, special shapes, and strict filling regulations. In these vehicles, the driver is not just dealing with weight, but with weight that can move around inside the tank. But even proper loading won't help if the speed is too high. The danger of high speed is that the lateral load during a turn increases very rapidly. The driver may feel that the tractor is still handling confidently, the steering is responsive, and the cab feels stable. But the trailer behind is already shifting its weight to the outer wheels. The inner wheels are unloaded, and the stability margin disappears. And if, at that moment, there's a sharp steering input, a bump in the road, or a crosswind, the system can go beyond its limits. That's why a truck's safety isn't just about the metal. It's about how it's driven. Engineers build in a margin of strength and stability, but every day, the driver decides whether that margin will be preserved or used up. Smooth steering, slowing down in advance, maintaining the correct path, and paying attention to the wind and the road. These are not mere formalities. They are part of the job of driving a long vehicle. A tractor-trailer cannot be driven like a passenger car. It requires thinking ahead. Modern tractor-trailers assist the driver with electronic systems. Stability control systems can monitor wheel speed, steering angle, braking, and signs of dangerous roll. If the electronics detect that the vehicle is approaching its limits, they can reduce traction or apply the brakes to individual wheels. But this isn't magic. Such a system doesn't make a tall trailer shorter, lower the load, or eliminate crosswinds. It simply helps prevent the vehicle from crossing a dangerous threshold too abruptly. Now we can put the whole picture together. A tall tractor trailer doesn't tip over simply because it's heavy, nor is it because it has a powerful engine. Its stability is provided by an entire system: the fifth wheel, which transfers the load to the tractor; the weight distribution, which balances the mass between the axles; the frame, which resists bending and twisting; the suspension, which keeps the tires in contact with the road; the wide wheelbase, proper loading, and the driver's speed and maneuvers. That is exactly why a truck isn't just a big car. It's a distinct engineering entity. It turns differently, carries weight differently, reacts to wind differently, and has a different margin for error. A passenger car is short and low, so it's more forgiving of sudden movements. A truck is long and tall, so it requires smooth driving, careful planning, and respect for the laws of physics. Where does the true limit of stability begin? Not when the trailer is already tipping over. It begins earlier, when the load is raised too high, when the driver enters a turn faster than necessary, when a crosswind picks up on a bridge, when the steering wheel is turned back too sharply, when the inner wheels are still touching the road but are already bearing almost no weight. The limit begins where the margin of safety built in by engineers is depleted faster than the driver can restore it. And now the original mystery becomes clear. The tall semi-trailer doesn't tip over simply because its height is offset by a system of solutions. It's designed to handle weight, wind, turns, braking, and rough roads, but it hasn't defeated physics. It's built around it. Every axle, every tire, every joint, and every kilogram of cargo works to prevent dangerous forces from building up all at once. That is the beauty of heavy engineering. From the outside, we see an ordinary truck, a cab, a trailer, wheels, and the road. But in reality, what we're looking at is a moving system of equilibrium. What appears to be brute force turns out to be a precise balance. What looks unstable is held together by careful calculation. And the next time you see a tall semi-trailer on the highway, it's important to remember, it's not just driving. It's constantly maintaining a balance between mass, speed, the road, and the air. And if you were curious to find out why a huge truck with a high semi-trailer doesn't tip over at every turn, please like this video. And if you enjoy breaking down complex technology in simple terms and understanding how the everyday things around us actually work, be sure to subscribe to the channel. There are even more engineering breakdowns to come, after which ordinary cars, roads, and mechanisms won't seem so simple anymore.